So hello everyone and welcome back to the Migration and Upgrade Centre. My name's Stephen Ball and I'm joined here again by our senior experts Al Manarino.
Hello.
And also Mary Kelly.
Hello.
So last time out we looked at the top 5 things to consider when converting applications, and in this video we're going to take our theory and put it into practice as we upgrade from an old pre-Unicode application that uses the BDE up to the latest RAD Studio 10.4. So like many people converting their applications, the key driver here is to show how to get the application supporting 64-bit Windows, and also to we're going to cover warts and all what we have to do to make that move. So the application we've chosen to have a look at is the Mast app demo from C++ Builder 6, and it provides a number of migration challenges, elements to look at along the way, but it's also one that's relatively easy to look at, so we'll take that as we go through. So Al, Mary, we've got the app here running on the C++ Builder 6 version. So what's the first things you notice here?
Well, we're going to need to check out the icons on Windows 10. I have a feeling that as we move up, the change in the resolution support in Windows 10 is due to high DPI is going to cause the icons to look really small on most machines.
Yeah, no, agreed. I also think we might need to check out what's behind that help button. Our Macs have changed the help systems a number of years ago, so that could be an external dependency that we need to modify. So I tell you what, do you want to just pull up the code there and let's have a quick search behind the help button. Yeah, I can see the first item there. It's a HLP file, so we'll need to get that updated to a CHM.
So I'm also curious to see what's behind some of these other buttons. So let's try the browse button.
All right.
Looking at this orders by customer screen, if we look at the scroll bars there, we might be able to use a little more screen space. So this is another area we can look at for UI modernization.
Yeah, and I think we'll also gain some usability wins here with updating this calendar to the VCL calendar view in 10.4.
Yeah, no, agreed. It might be worth a quick look at the cust query form in the project there.
All right, let's find the date form.
So, there seems to be, we've got a property for the date time there, and we've got the read and the write. Can we have a look at the source there? But at least it's using the date off the control, which is kind of cool. But I think having those getters and setters, it could be quite easy then to actually switch that out with the modern Windows 10 controls. That should be a really, really quick thing to do.
Yeah.
Okay, so should we have a look behind the data? Yeah, come on.
Yeah, see in your list there's a data module, so I'm curious to see what's inside the data module.
Yeah, let's go ahead and open that up.
I assume there's a form that goes with it, but just looking at the code here, I'm seeing T database, T query, T table. So this to me is the good old BDE, the Borland database engine. So this is definitely going to be an issue on Windows 10 64-bit, because as many of you know, about 20 years ago, we deprecated the BDE. So it was never tested or certified on these newer operating systems like Windows 10 64-bit. It's never going to support Unicode. It's never going to support 64-bit. So if one of our criteria is to move this app to Windows 10 64-bit, the BDE will not work for us. So we'll need to migrate off of the BDE to a newer, more performant data access component like our FireDAC component.
Yeah, I think we've got the BC demos database there, pointer paradox. So yeah, that's definitely going to fail our 64-bit requirements.
Yeah, I've been using the InterBase database pump recently to update some of our customers from Paradox to InterBase. So this would be a really sensible path, especially with the runtime free IB Lite version.
Wonderful. So I'm agreeing so far with everything we discussed about how to migrate this legacy CBuilder 6 project over to the current CBuilder 10.4 and get it to run on Windows 10 64-bit.
Okay, cool. All right, team. So I think we've had a quick look around. We seem to be getting a plan together. I think first things, let's get the code to open in 10.4 without reporting any component errors. Then sort out any Unicode analysis that we need to do. And the database side of things might make sense to go straight to FireDAC because we know we're going to have the challenges with 64-bit for the BDE. Al, is that something you can do?
Yes, I'll take care of showing how easy it would be to migrate off of the BDE and over to a newer, more performant data access control like FireDAC. So I'll take care of that one.
Cool, thanks, Al. And then we need to point this to Paradox ODBC for the initial test. But then, let's look to maybe get this into InterBase so we can take 64-bit support into the equation and also enable multi-user access onto the database.
I can pick that up.
Okay, great. Thanks, Mary. Then I'll sort out the help file, which just leaves the kind of UI modernization elements to do.
I know of a good site for us to get some icons for multiple resolutions that we can swap in with the modern T-Speed button, which supports image lists. And I can also sort out the calendar controls.
Okay, great. So guys, I think we have a plan. Let's check this CBuilder 6 code in, and then I think it's over to you, Al, to get the initial bit done.
Excellent. Stephen, Mary, and myself will be working on this C++ Builder code migration from different locations, so it's a great idea to upload the project code to a version control system. C++ Builder has built-in integration with 3 of the most popular version control systems, Git, Mercurial, and Subversion. For our project, we will choose to use Git. So here we see our C++ Builder 6 Mast app project uploaded to GitHub at this Git URL. So now using GitHub, we will be able to collaborate and look back at previous versions of our work, and Git will keep track of all of our changes to the code. Now, to get the GitHub project onto our local disk, using the C++ Builder 10.4 Sydney IDE, we can use File, Open from Version Control, and select Git. Click OK. And now for the Git source location, we will select our GitHub URL, and for the destination, we will create and select an empty folder. I'll go to my documents. I have an empty folder called C++ Builder 6 Mast app that I'll use as my empty folder as my destination, and click select folder. Click OK, and our GitHub project gets cloned to our local drive. So here we get to select the project file for our C++ Builder 6 Mast app application, which is the mastapp.bpr file. Click OK. And our GitHub project gets successfully cloned to our local drive. Looking at the source code from the GitHub repository, now on our local file system, we see that the project file for the old C++ Builder 6 project is a .bpr file. The BPR file was the extension for C++ Builder 1 up to at least C++ Builder 6. Now, since the separate IDEs for C++ Builder and Delphi were merged about 10 years ago, the default project extension for C++ Builder is now a .cbproj file. So the first tip I have for you is do not let the current C++ Builder 10.4 Sydney try to convert your old .bpr project file to the new .cb project format. In fact, if you try to open up the old .bpr file in C++ Builder 10.4, all you get is the file opening in the editor like this and showing you the contents of the .bpr file in XML format. Too many aspects of the project file, from the .bpr to the current .cbproj file, have changed between the year 2000 and now. So my advice for the CBuilder 6 to CBuilder 10.4 project migration is to first copy all of the old CBuilder 6 project files into a new folder, like we have done so already. Next, in your C++ Builder 10.4 IDE, create a new C++ Builder project of the same project type. So in our case, it'll be a new Windows VCL application C++. Next, we will save the new project to our new folder, File, Save Project As. We will save our project to our CBuilder 6 Mast App folder. For the file name, for now I'm going to just rename it to Remove Me to remind myself this is the auto-generated unit1.cpp from the new C++ Builder 10.4 project. Since it's not needed for our application, later on we will select and remove this file from the project. For the precompiled header, I will call this my Mast App precompiled header. And for the project file, it'll be our new Mast App project for C++ Builder 10.4. Next, we want to use project add to project, and we want to add all of our C++ Builder 6 project files. So that's all the .cpp, .h, .hpp, and .dfm files, plus any resources from our old C++ Builder 6 application into our new C++ Builder 10.4 project. And the first error we get trying to open these files in C++ Builder 10.4 is error reading from customer by invoice report, class T quick rep not found. So let's just click cancel for now. And this is followed by error creating form, class T quick rep not found. Let's click OK. The next error we get is unknown database, alias MAST. For now, let's just click OK. The third error we get trying to open the CBuilder 6 files in CBuilder 10.4 is this unknown database alias BC demos error. For now, let's just click OK. And we get another unknown database alias MAST error. So for now, let's just click OK, and we'll come back to these errors and explain what they are and what we need to do to resolve them so we can move forward with our project migration. And the last warning we get is ignoring the old CBuilder 6 mastapp.bpr file, because we cannot add another project to a project. So that's fine, because for our C++ Builder 10.4 project, we will be using its new .cbproj file instead of the old CBuilder 6.bpr file. So here we can just say OK. So now we see the CBuilder 6 Mast App project files in our C++ Builder 10.4 Sydney IDE. Recall in our introduction, we mentioned that this CBuilder 6 Mast App application uses the BDE to access local paradox tables. So let's now look at the data module, the datamod.cpp file for the BDE components. So here we get an error saying error reading from mass data, class T table not found. So this error tells me that the BDE is not installed in our C++ Builder 10.4 IDE. So as part of this migration, we will need to install the BDE into our C++ Builder 10.4 IDE. And later in this migration, I will show you how you can install the BDE into your C++ Builder 10.4 IDE for backwards compatibility. So at this point, we can just click Cancel. So now, since this project is under Git control, any changes we make to this code will be logged by Git. And lastly, from the IDE Project Manager, I will remove the auto-generated unit1.cpp that I renamed to removeme.cpp from this new C++ Builder 10.4 project, since it's not needed for our application. So select the file, right-click, remove from project, remove this item from the project, the removeme.cpp, click yes. So now that auto-generated unit1.cpp has been removed from our C++ Builder 10.4 project. So all of this is great. Going back to the cbuilder6.bpr file, the old .bpr file still has value for our migration. So as you can see here, you can still open up the .bpr file inside of C++ Builder and treat it as an XML file to see, for example, what headers you need to add to the application, plus other useful information like what libraries the project used, what packages are needed, plus a file list of all the files that are needed for this project. So I stick with the advice of don't let C++ Builder 10.4 convert your older CBuilder project file. Instead, do what we did here. Copy your files into a new folder, create a new project of the same project type, in this case a C++ Builder VCL project, and then add your source files to it. It's a little more effort at first, but it will save you a lot of time later on. And I stick with this advice even if your project has hundreds of forms and or hundreds of classes in it. And one more note to mention is, if you had third-party component extensions for CBuilder 6 or any other legacy CBuilder project, be aware that some of the freely available libraries from the past may no longer be available or still supported. However, the good news is the range of components that are bundled with CBuilder 10.4 is much greater. So if any old component is missing, there is a good chance you may be able to replace it with an equivalent new one from C++ Builder 10.4. So now our project is under Git control. And when we make any changes, we now have Git control to be able to commit, pull, show log, clean, and or push those changes. So all of that is great. To get the BDE for C++ Builder 10.4 Sydney, you can log into your registered products portal page at my.embarcadero.com using your Embarcadero developer network username and password to log in, and then click this cloud download button on the left panel and search and find the BDE for Rad Studio 10.4 and click the download button to download the installer for the BDE for C++ Builder 10.4. Run the BDE installer This will install the BDE runtime headers into your C++ Builder 10.4 IDE. The BDE has been installed successfully. Click Finish. Next, we also want to see and use the BDE design time components, like the missing T database component, in our C++ Builder 10.4 IDE. So we will also need to install the BDE design packages for the BDE components. We do this from our C++ Builder 10.4 IDE by selecting Component, Install Packages, clicking the Add button, and we browse to the bin folder of our 10.4 IDE installation, and we search for and select the package called DCL BDE 270 and click Open. Now when we look at the install design packages, we now see we have Embarcadero BDE DB components listed as one of our install design packages. And if we click the components button, we see we have the BDE installed components, including our missing T database component. We also see we now have T query, T table, and all the other needed BDE components for our application. So now that we have the BDE installed, let's try and reopen the MAST app project and see if we resolved our missing class T database not found error. Let me again select the customer order form that uses the BDE, and we see now that the customer order form opens up just fine without any missing BDE components. So all of this is great so far. Let me now pass this migration to Mary to explain and fix those errors we got opening this project in C++ Builder 10.4. The unknown database, alias mast, and BC demos, and the T-Quick report not found error.
In MastApp, our data module is currently using one of the older paradox tables in C++ Builder. The aliases mast and BC demos are actually the DB demos paradox example that we shipped with both Delphi and C++ Builder. Soon, we'll be migrating entirely away from Paradox to InterBase, but to quickly solve these issues, we're going to go into the data module components and make the switch to DB demos to get prepped for our Unicode, FireDAC, and UI updates. So if we go ahead into the database editor, we can see here that the name it was given is called MAST. We're going to switch this to DB demos. And click OK. So now the new database and alias name are now DB demos. If we go ahead into our orders to cust by order, items, parts, employees, and vendors, all we have to do is go through and just change this to DB demos for each of them. So just going through all of the rest of these, DB demos for all of our data source components. Now that will end up getting rid of the unknown database alias, either mast or BC demos, and we'll actually be able to connect to our backend data source. And now when we go into our DB demos data module, we no longer have the error unknown database alias mast alias BC demos that appears. We're now connecting to the DB demos database on the back end. The error that we're seeing right now is what you run into when you open a project that's missing third-party components. Now, a question we always ask is what third-party components or libraries are you using in your older C++ Builder projects? The reason we ask this is because third-party plugins need to be rebuilt in the current C++ version. Now, having the source code makes this a lot easier, and if the libraries are still maintained by a group or even available as open source, then you can still use them with minimal to no changes. Now, on the other side, if the components are not available for our current release, then you still have a few options available. You can either switch to a different component set, or you can just remove the components entirely from your project. While Quick Report is still available today as a third-party reporting component set, we are going to choose to remove it from our MastApp application. So let's go ahead and see what we need to do to get the library code removed. To get started with removing a third-party component from C++ Builder applications, such as the MassApp application. Now, before we get started with actually removing the components for our reporting component set, we need to know exactly where it is within the application that our reports are either being generated or called from within the code. Now, specifically for the MassApp application, the majority, if not all, of the reporting components all fall directly from the main form. So we'll be mostly sticking within the main files to remove the reports component from Quick Report. Now, if we take a look at reports, we can see here that the on-click event property is report button click. And we can also go ahead and see within our header file just how many procedures we actually have to remove for this application to no longer draw any dependencies to the Quick Reports components. Looking at our header file, we can see that the report button click along with file printer setup click and file print report click are also going to have to be removed. The print invoice report, the print order report, and customer report. So overall, it looks like we have 6 different procedures that we're going to have to remove, along with the T-speed button for reports. If we look at the main source code, we can see the customer, order, and invoice reports all at the bottom in our include statements. I can go ahead and remove or comment these headers out. Usually you would just remove them, but I'll only be commenting out the code instead. We can now work through commenting out the code for the procedures in our source file. Since we no longer use any printing in our application here either, we can just comment out that as well. And now that the code is inactive, we can comment out the procedures in our header file. We can go back into our design page and remove the report button, and then we can reset the rest of the buttons on the main form to their new position without the reporting components. Moving into the MassApp project file, we can scroll down to comment out and prevent the forms from being created from within the project. Our last step will be to remove the source files from the project manager. The 3 files were the customer report, invoice report, and order report. Just finished removing these, and now our application has 0 or no dependencies on our Quick Report components anymore.
Now that we have the BDE installed into our C++ Builder 10.4 IDE, let's now look again at the data module that uses the BDE for data access to local paradox tables. Our data module is this data mod form. In this data module, we see we have the BDE components like the tDatabase component, tTable component, tQuery component, and the BDE tDataSource component. As we discussed earlier, this CBuilder 6 MassApp application is an order entry system that uses the Borland database engine, the BDE, for access to paradox tables. This application uses and interacts with the orders table, customer table, vendors table, items, parts, and employees table. As many of you know already, the BDE has been deprecated for the last 20 years, so we really need to migrate off of the BDE to a newer, more performant supported data access layer that supports Windows 10 64-bit and modern security standards. Looking at the Data Explorer tab in C++ Builder 10.4, we see we have DB Express and FireDAC for data access layers. Now, since the BDE is deprecated and Embarcadero advises not to use the BDE for any new projects, since the BDE is no longer supported and the BDE was never tested or certified to run on the newer operating systems like Windows 10 64-bit, and the BDE will not support 64-bit Windows applications, and the BDE will not support Unicode. So Embarcadero's advice is to move off of the BDE to a newer, more performant data access component that is certified and supported by Embarcadero. Today, our newest and most performant universal data access components are called FireDAC. So now let's take a look at a few approaches you can use to migrate both your C++ builder code and forms from the BDE to FireDAC. One good point is the architecture of the FireDAC database access library in C++ builder is very similar to the now deprecated BDE Borland database engine. And this was one of FireDAC's original design goals, to be a replacement for the BDE. And as we see here, on this DocWiki page, BDE name counterparts for FireDAC, we see a table that lists the main BDE names and their counterparts in FireDAC. So for example, a BDE T session gets replaced with a FireDAC T FD manager. A BDE T database gets replaced with a FireDAC T FD connection. A BDE T query gets replaced with a TFD query, and a BDE T table gets replaced with a FireDAC TFD table, plus all the other BDE names and their counterparts for FireDAC. And at the bottom of this DocWiki page, it says you can find the full list of all the BDE name counterparts to FireDAC in a file called FireDAC Migrate BDE text in your FireDAC samples folder. So now going back to the data module in C++ Builder, one approach to migrate off of the BDE to FireDAC would be to do a search and replace on the BDE syntax name and replace it with the FireDAC equivalents. So for example, a BDE T database becomes a FireDAC T FD connection, and a BDE T table becomes a FireDAC T FD table, and a BDE T query becomes a FireDAC T FD query, and so on. Trying the first approach using search and replace to migrate from the BDE to FireDAC, we can use the IDE's search, find in files, and let's see if we have any BDE T database in our code or forms. We will search for whole words only, and we will search all files in the project. Here we see we have found a few places where we are using the BDE T database in both the data module form and the data module header file. So in the data mod header file, there's really only one occurrence of the BDE T database on line 59. So here we can select the BDE T database and then select search, replace, and we want to replace our BDE T database name with the FireDAC T FD connection, and let's say OK. Replace this occurrence of T database, yes. So now our BDE T database has now become a TFD connection for FireDAC. Next, we need to replace the BDE T database name in the data mod form. We can do that by selecting the T database search item, right-click, edit source, and now we have our form displayed in our IDE editor like this. And here for the form, we can replace the BDE T database with our FireDAC TFD connection. So that's done. Save all. So now as a check, if we reopen our data mod form, we now see that our BDE T database component is now replaced with a FireDAC FD connection. So that worked great. So we can now continue with this manual search and replace approach to replace all of the BDE names as listed on this web page with their FireDAC counterpart name on all of our forms and in our code. Or another approach is to use a third-party utility like this Delphi parser BDE to FireDAC migration wizard for C++ Builder. This utility, as described on its web page, scans your whole C++ Builder project code and migrates the BDE code to FireDAC. Let's now take a quick look at how this utility works. Here we are running the Delphi parser C++ Builder migration wizard for converting BDE code to FireDAC. For the utility, we will select our CBuilder 6 Mast App BDE folder as our source folder, and we'll create a new folder called CBuilder 6 Mast App FireDAC for our modified code. Here are the highlights from the utility's processing. It first copies our project to a new folder, then it converts our binary form files to text, then it loads the project files to runtime memory. Next, it scans the code for database objects and references, and then it scans our data modules for database objects. So the utility scanned 8,755 lines of code in our CBuilder 6 Mast App application, and 83 objects were found that need to be migrated. The utility tells us it looked at a total of 8,755 lines of code in our CBuilder 6 Mast App project with 83 data objects in 56 files. It fixed 144 lines of code by replacing functions param variables, replacing local variables, replacing global variables, replacing objects reference code, replacing class declaration, replacing object modules, fixing environmental code, and adding and removing C++ header files. So now, after you complete your BDE to FireDAC migration, when you look at your new data module form, we now see our new BDE to FireDAC migrated data module, and we see that all of our BDE items have been migrated to use FireDAC. So now, for example, instead of the BDE T database component, we now have a FireDAC T FD connection. Instead of the BDE T table component, we now have a FireDAC T FD table component. And instead of a BDE T query component, we now see we have the equivalent T FD query component for FireDAC. So now we see we have and are using FireDAC components instead of the BDE and all the other FireDAC equivalents from the BDE. So all of this is wonderful. Now, since we made many changes to our forms and code migrating from the BDE to FireDAC, I want to now commit these changes to our Git repository. So I'll select my Mast App executable, right-click, Git, commit. I want to commit from the repository root. So here's all the changes we have made to our project code. Let me add in a comment like migrated from BDE to FireDAC, and let me go ahead and commit these changes. So the commit completed. So now our changes are in our Git version control system for the other members of the team to continue working on this C++ Builder migration.
Since we've migrated the application from the BDE to FireDAC, we can either choose to keep our Paradox database the same, or we can move to a different SQL option. In this case, we're going to make the switch to the InterBase database. Now, InterBase is a highly scalable, powerful, embeddable, and encryptable database that works across several different platforms, including iOS and Android. Something only a few databases out there do while running natively on these platforms. It's extremely lightweight and has a tiny footprint, so you can imagine how quick and powerful it is by not bogging down the system it's running on. It has near zero administration, so you can deploy it and you don't need a DBA to constantly maintain it. As far as moving our application from FireDAC to InterBase, there's this nifty little tool called the InterBase Data Pump. It's from a group called Clever Components, and it's going to take any ADO, BDE, or InterBase data source and actually migrate it to our targeted InterBase databases. So it's a free download, and we can take a look here, see the steps, and then download from there. So once you have the InterBase Data Pump open, you're going to go ahead and select the database and then also set up all of your properties. So in this case, we're using the BDE and we're using the DB demos. It automatically popped up on my machine, but in the event that you have other data sources from the BDE, you can go through and click them. You have your username and password, which typically are already inserted anyway. You'll test the connection and make sure that it's passed. Then you can go through and set up any of the properties specifically, so relating to the pump. Maybe you need to disable any of your triggers. Maybe you need to empty out the destination tables before the pumps, or even updating generators. You can also go through the string field properties and building the relationships, typically case insensitive fields and table comparisons. Now we're going to go through and choose our destination database properties. Now, in some cases, if you've already created the InterBase database before this, then you can just toggle through and specifically choose where that database is. If you don't have a database already created for it, you can go into IB console, click on the database, either right-click on this database and create the database, or you can click up at the top of the menu, create database, go ahead and create the database with the title that you want. In this case, I'll be using DB demos. You can go through with the options such as changing the size of the page, also adding in something like embedded user authentication for additional security purposes. You can choose to save the password or even use the alias for database connections. Now we can choose our dbdemos.ib file. We can go ahead and test that connection, and it has passed. Now we're going to want to build out a SQL script for the source so that as we're moving from FireDAC to InterBase, it creates the schema script that we just install then into InterBase. So we're going to go ahead and build our SQL script. It's going to save the script to some file, in this case the convertbde.sql. It will rewrite over this additional text file that I already had from another migration. It'll go through and match up with the dialect, any specific character default sets that you may set, and it'll also create the generators for auto-incremented fields. You can choose to add them in manually, so you can add and go through any of the tables that you have and specifically pull in those fields. Or you can also just let InterBase Data Pump create those generators for you. So all of these fields more or less match up as a one-to-one with what InterBase is looking for between the migration from the BDE to InterBase. So we can go ahead and click Start, all fine, and it opens up this converted BDE script, and as you can see, it really just creates the schema for the entire script. So now we can go into our IB console, into the interactive SQL, and we'll be able to add this query, load the entire script, and run the script from there, so that when we have our database created, we'll be able to see that all of the schema has now matched up, and we've successfully moved the schema from our FireDAC database to our InterBase database. There's still no data yet, as we haven't actually used the data pump portion, but at least now we've completed half of our database migration. From there, we can click close and go into the order. Now, you can grab the definitions, and then from there it gives you these nice 3 steps where you can then build the relationships. So you can either choose to do this manually, or you can build the relations, and it will specifically look at each of these and make sure that as close to matching between the InterBase and FireDAC tables as there can be in terms of data types. You can also do the exact same thing using the generators. And moving on to step 3 with the data pump, I'll go ahead and click start. I'm going to get this message about the destination database is in forced writes mode. This is just because my IB server is currently set to that. So it's going to make the pump a little bit slower. I can go ahead and open up my InterBase database IB console. In the process of that, I can go ahead and log into my database, and it should be just about done by now. So I'm going to go ahead and see if my data was migrated, and it looks like all of my data for all of my tables, let's check up a couple more, has actually been migrated over. So now I can go into RAD Studio, open up my C++ Builder application, and go ahead and move over to my data module. I can right click on my database connection, set the driver ID to IB for InterBase, go ahead and toggle to my database location, which is dbdemos.ib. I'll enter my username and password. And the sysdba master key for the password are the defaults for InterBase. Can test that connection. My connection has been established successfully. Now we'll go back to the main form where we can then run our application. And we'll let this compile. It shouldn't take too long. A few warnings. And our MassApp application for C++ Builder was able to run. So if we go ahead and click on parts, we can see here that the data is now being pulled from InterBase rather than from our FireDAC tables. So now we were able to successfully move a database from FireDAC to InterBase and make that switch as well from the BDE to FireDAC.
One additional item to discuss for this C++ Builder migration is to compare the Borland Classic compiler used in the legacy C Builder 6 Mast app project with the current Clang enhanced compilers we now have in the C++ Builder 10.4 Sydney IDE. The default compiler for C++ Builder 10.4 is the Clang compiler, but C++ Builder 10.4 still also includes the older Borland Classic compiler. You can set the compiler to use from Project, Options, C++ Compiler, and here you see C++ Compilers Win32. Use Classic Borland Compiler is set to false, meaning this project will use the Clang Enhanced Compiler by default. Let's first use the Classic Borland Compiler to build this C++ Mast app project in C++ Builder 10.4 by checking the box to true and save. Let me now build this C++ Mast app project using the older Classic Borland compiler. So it's done, and we see from the messages view we are using the older Classic Borland compiler, the BCC32 compiler, and we see from the build dialog using the older Borland Classic compiler, we have 0 hints, 0 warnings, and 0 errors. So that's fine. So we see that the project built just fine using the Classic Borland compiler with no errors. And we can also run this Mast app application built using the Classic Borland compiler. And it runs just fine. Next, let's build this project again, but this time we'll use the Clang Enhanced compiler. To change the compiler, Once again, we use Project, Options, select C++ Compiler. So now instead of saying use Classic Borland Compiler set to true, we will uncheck the true, making it false. So now, instead of building using the Classic Borland Compiler, the project will build using the new Clang Enhanced Compiler. Click Save. Let me first clean the project to remove any old Borland Classic Compiler files. Now let's build the project, but this time using the newer Clang Enhanced Compiler. We see using the newer Clang Enhanced Compiler, it takes longer to build than it did with the classic Borland compiler. Here we see from the messages view that we are using the newer current Clang Enhanced Compiler, the BCC32C, and the C tells us we are using the Clang compiler. This time, using the newer current Clang Enhanced Compiler, the BCC32C, we see that we have 0 hints, 0 warnings, but 4 errors. And looking at the 4 errors, they are all coming from our data module. So the first error is value of type int is not implicitly convertible to a DataDB tlocate option. So here we see that the newer Clang Enhanced compilers are stricter than the legacy classic Borland compiler. You have heard me say that C++ Builder 10.4 features Clang Enhanced compilers. So what do we mean by enhanced? Looking at our DocWiki page for C++ Builder 10.4 Sydney, Clang Enhanced C++ compilers, we see that C++ Builder 10.4 includes 6 separate compilers. We have a Win32 Clang Enhanced compiler, another Win32 Clang Enhanced compiler that uses Clang command line flags, making it compatible with other Clang-based compilers, a Win64-bit Clang Enhanced compiler, an iOS ARM Clang compiler, an iOS ARM 64-bit compiler, and an Android ARM compiler. The C++ Builder 10.4 Clang Enhanced C++ compilers are based on the open source Clang project, which means they are an entirely new code base benefiting from the input from hundreds of developers. We extended them ourselves with support for the language features we offer, such as properties and other features that work in our ecosystem. And that's what we mean by enhanced. The C++ Builder 10.4 Clang Enhanced compilers offer many significant improvements compared to the previous generation C++ compilers, such as the legacy Borland Classic compiler, the BCC32, the 32-bit Windows compiler. For example, exception handling is much more robust, the language standards is much better, supporting C++ 17 on Windows, whereas the older Borland Classic compiler only supports C++ 03, which is 17 years old now. With the C++ Builder 10.4 Clang Enhanced compilers, you get much safer coding. Using the new, safer, and more expressive C++ features, you get faster performance for compiled code. Our C++ Builder customers have reported up to twice as fast runtime performance just by rebuilding with Clang, and many more specific features using Clang. And just to name a few of the notable differences between the C++ Builder 10.4 Clang Enhanced C++ compilers and the 2 previous generation C++ compilers, the C++ Builder 10.4 Clang Enhanced C++ compilers are also preprocessors when run with the -E switch. And for 64-bit Windows, there is also a separate CPP64 executable preprocessor. The C++ Builder 10.4 Clang Enhanced C++ compilers enforce template two-phase lookup. The Clang Enhanced C++ compilers allow a default argument only in a function declaration. The previous generation C++ compilers allow default arguments in a function pointer or closure declaration as well, plus many more enhancements that are listed on the C++ Builder DocWiki page here for differences between the Clang enhanced C++ compilers and previous version C++ compilers.
So let's have a look at the help section of the app. I've got the source code downloaded here and the master app help file, which I've copied now onto my desktop. If we try to double click and open this up, we can see it takes us directly to the Microsoft website, where it tells us about the error opening help in Windows-based programs. And this is a format that is no longer supported on Windows 10, and in fact hasn't been available for many versions of Windows. If you are encountering this version issue, then what you can do is either re-export using your existing help program, or you can use one of many applications available to import and then re-export out the help file into the new format that is supported on Windows 10. So I had a quick search around. I managed to find Help NDoc, and they've got a free evaluation purpose version, which is great, ideal for testing. Obviously, if you do want to use it commercially, then there's a price to pay for the commercial version, a couple $100 or something. So you know, a pretty cost-effective way to go rather than having to rebuild the whole help file. So let's have a quick look at doing that. So I open up the Help NDoc here, and I'm just going to go File, New Project, and we'll call this Master App. And I'm going to create an empty project here. And then what I can do is import in our existing help file. So this is why I put it onto the desktop to make it very easy to locate quickly. And let's import that in. And we can now see that we've got our content in here. Now, the one thing I will say, just from past experience going through this, you do need to go and make sure that you set up the line spacing, just check any line spacing issues, and then generate the help files. So I'm just going to go here and let's just change the paragraph here, and instead of having it at 16 points, I'm going to set this to at least a single line. I'll do that on all those and then just export out. Okay, so now the paragraphs are all set up, and the thing about using line spacing compared to font weighting is that Windows 10 obviously has multiple different resolutions and different things going on, and it just means that you'll get a cleaner help file. So let's go generate the help out, and I'm just going to generate the CHM. I don't need all the other versions here. And there we are, we're done. So let's go and have a look, and we should now have a help file that we can open up and we can see content in. Let's just work our way through here. Looking good. Right, so now we've got a help file. Now we need to make sure that it works with the same calls on Windows 10 as it has done in the past in our app. So I'm just going to take a copy of this help file and pop that on my desktop for now, just so I don't lose it. Let's close that. And let's jump into Rad Studio. Now I've created a new project here, and I've added into the project the main CPP file, form and the header from the previous application. So let's have a quick look on the form here. And we have a look at the code behind the help button here. We can see we've got this application help command help context of 0. And if we have a look at the actual main application CPP file, we can see in here that the help file is being set as the application starts up. So let's just go ahead and we'll copy that, and that's pretty much it. So let's see if we can now get this to work in a new test application, just to make sure that all the help file context is working before we merge that into the main branch. So I'm just going to create a new VCL C++ application. I'm not going to save the changes to this project here. And we're literally just going to put down a single button. And into there we'll paste in that. Oh, that's the wrong part of code. It was application help command, and it was help contents. .0. Okay, so that was the command to launch the help. The other thing we need to do is just tell it what the actual file is called. So if we go to have a look at the project source, in here we should be able to now paste down the other line of code. And let's update this to the CHM file that we have got. So the other thing we need to do now is we just need to save the project. And the reason we need to go to save the project, and I'm going to put down a new folder in here, 007 help. The reason we're going to save the file, or save the project should I say, is that at the point that we build this for the first time, the project will then create the folder structure for the output. And whilst we're doing the testing here quickly, this is on a debug version, so a debug build. We've got the debug build configuration, so let's just go show an explorer. We can see in here we've got the Win32 debug, and then there's our project. So if we try to run that at the moment, it will not find the help file because the help file is not there. So let's just go and move this now into our folder. Now if we launch our application, we can now see that we've got this unable to find table of contents. Okay, so this is actually quite an easy one to fix. Because the CHM is based on HTML, we actually need to just provide a couple of additional lines at the point that we launch the project. So in the top section here, I'm just going to copy this, and we're going to include it's VCL.html help viewer for HPP, and then we just need to set pragma package smart initiation, and then also one more pragma. We need to link VCL HTML help viewer. Okay, so this will initialize the HTML help viewer within the application, and I think that's all we need to do. So let's go ahead and build and run. And now we can see that we have our help file opening up, which is brilliant. So we're now ready to kind of integrate these modifications into the main branch and use our help.
We've gotten to the point in our migration process where we're wanting to update the UI and give it a more modern look and feel. such as adding Windows 10 styling, or even being able to take advantage of new Windows 10 features such as high DPI on multiple monitors. With Windows 10 UIs, they need to be able to scale according to the DPI of the target monitor. And when you have images or other graphical elements that aren't scaled properly, they can look blurry, too small, or even too large in some cases. During our planning meetup, we discussed a few things that we wanted to change. So the first thing that we're going to change is the icons on these T-speed buttons. They look a little bit outdated, and we want to give them a more modern look and feel. Now, if I go ahead and I run this application, we can see right off the bat that there's definitely an issue with the sizing of the images and the other graphical elements within the application. I'm running a machine that happens to have 2880 by 1800 for my screen resolution, so the images that we have here are quite small. So that's going to be the first thing that we go through and change. With RAD Studio 10.4 Sydney, you're able to include some scaling high DPI multi-resolution images in your VCL applications. And you do this by using two specific components, the T image collection component and the T virtual image list. When paired together, you're able to load multiple resolutions of the exact same image into the image collection here. And then the image list holds the set of images from the image source itself. The image list holds a set of images that are then sourced from this image collection and then presents them at a specific size, say 16 by 16 or 48 by 48. Now the images are then smoothly resized and scaled, and the image list's actual presentation resolution is then changed based on the DPI of the target machines. So there's this great website called Android Asset Studio that is, as listed, a collection of tools that easily generate assets such as launcher icons. In this case, we're going to look at the launcher icons. Now, one of the cool parts about this is that it'll take an image, it'll take clip art or even text, and it will actually create them at different screen resolutions. So for instance, 16 by 16, maybe 48 by 48, and it'll actually create them so that you can download them as the pre-packaged resolution, so that when you want to add them to projects, you don't have to worry about how an image is going to look, if it's going to be blurry versus clean and crisp. Moving back into our image collection list, I'm going to go ahead and show the image collector editor. So I can just go here and click on add. And I can go through each of these, and you'll see here that the icons show up under selected images as different resolution sizes. So as I add in more, you can see they're matching up with the name for each of these icons. So I've got a 72 by 72, 48. I'll go ahead and just add in the rest of these real quick. And we now have icons from 48 to 192. If I go ahead and apply those, then I can move into my virtual image list. Now, if I set my virtual image list to the image collection, then I can open up the editor for the image list and then add in the icons. So I'll click OK, and now it's resized my icons under the selected image. Next, I can click on my T-Speed button, find the images, choose my virtual image list 1, and also the name of the image as how it's listed in the T virtual image list. If we run the application again, then you'll notice that the image has now been resized properly compared to the rest of my images. If we close out, we can go ahead and do the same thing with the rest of them. I already went ahead and added all of the 5 icons that I will be replacing. They all have the same pixel size, so no variation there. You can go ahead and click OK. Now going into the virtual image list, I can go ahead and add the rest of them. So I can say select all, can click OK. And now through each of the parts, I can actually go through to the images, add the virtual image list, and choose for each one of them. So for new order, we'll choose new order. For browse, we'll choose the search. And then for parts, we can use list. So we've now been able to update each of the icons. So if we go ahead and run the application again, then we can see that the icons themselves are very crisp and clean, and they also are scaled properly to the size for the rest of the application. Now, if we move into Browse, there was one other section that we really wanted to work on, which was defining of the calendar range. So this calendar looks quite old and outdated. So we're going to go ahead and replace it with the T calendar view that we have as part of Rad Studio. So we'll go ahead and close out and open up our pick date file. So we're going to expand out the form a little bit so that we can see a side-by-side comparison of the calendar view with the current calendar that we have listed out here. So from this calendar, as we can see, it seems like it's a little bit more outdated, while the T calendar view was actually designed for Windows 10. So it gives it a more modernized look, like you would expect from a Windows 10 application. So we're just now going to remove the components from the older calendar set, and we then will also change a little bit of the code in the back end because a few of the procedures and components will no longer be there. So the cancel is still stays. The next month, that's actually pre-built into the Win10 T calendar view, and we can get rid of the previous as it's also located there, and the title label as well. Now we'll just go ahead and reposition our new T calendar view on our form. Give this a little bit more space here. And then shrink back that form. Now we're going to go into the pickdate.cpp file first, and we are going to change and remove a few components and properties. Now, since we no longer have the calendar, but we do have the calendar view one, I'm just going to add the word view into my calendar. Now, calendar view does not actually have a calendar date as a property, but it does have date as a property, so I'm just going to remove that. I'll do the exact same thing as I did up above, remove the calendar and add the word view. Now, we ended up getting rid of the previous and next buttons along with the title label, so we're actually just going to remove them in our CPP file. Next, we'll go into the pickdate.header file, and we're going to end up getting rid of all three so that we don't run into an error there. Now, if we go ahead and run the application, and now we should be able to go and build our application. And now we have a running application with both new icons and a Windows 10 calendar. We've successfully run our MassDAP application using the 32-bit Clang compiler. And now we want to run it using the 64-bit compiler for C++ Builder. So our first step is going to be to expand out our target platforms and activating the Windows 64-bit targeted platform. Now we can go ahead and run the application, and we'll see if or what changes need to be made. As you can see, we have a 64-bit version of the MassApp application up and running. If we go into our project folder, we can then see that a Win64 folder was created under the debug configuration, and under there we can see that we have our C++ builder MassApp application available.
Okay, so we are almost at the end of the webinar now, and we've got all the main work done. So I thought it'd be just a useful thing to recap and have a quick look at the app now and also at the start. So we see the start one on the right-hand side there. The icon's been quite small, as we predicted with the move to Windows 10, that was going to be a challenge. And on the left-hand side, updated, all looking good. Should we delve in and have a quick look around? I think one of the other app modernizations was the calendar control as well, wasn't it?
Mm-hmm. You can see here we have the new Windows 10 VCL styling, and we can also open up the older version as well. You can see a nice big difference here.
Yeah, the animation just makes it a much nicer and smoother control to use, doesn't it?
Yes, very much so. I have a little bit more range, also with choosing dates as well, compared to having to click 100 times just to get to 1990.
Yeah, and I think one of the other things that we could also have done here, there's obviously the calendar drop-down controls that we could actually replace that bit. Instead of popping up a separate form, actually have the control all embedded in as well. So there's a number of nice options that we can pick up and take there. Okay, cool. And the help file's working, obviously, as well, which wouldn't be with the old version, which we've seen the issues with as we've gone through. And the database, obviously, we're now working on a 64-bit version, which we're able to use with InterBase as well. So some great modernization wins all around. Al, anything else that you want to kind of add in as a quick summary at the end here?
Wonderful. So during this migration, we got to look at the main items to consider migrating a legacy C Builder app to the current version. So basically, we looked at third-party libraries and components. We looked at any Unicode changes you may need to make if you were running a version of C Builder prior to C Builder 2007. We looked at the data access components, specifically, if you were using the older Borland database engine, to get off of that to a newer, more modern data access component like our FireDAC component. So we showed you how to migrate off of the BDE to FireDAC. Next thing we looked at is switching from the classic Borland compiler to the client compiler, a much more modern C++ compiler with greater optimizations. And then finally, we got to look at some new UI modernizations to make the application look more new and more modern. So all in all, migrating a legacy C Builder app to the current C Builder is a lot easier than anyone thinks it can be.
No, absolutely. And I hope you guys watching have found this useful. Mary, anything else that you want to kind of say at the end here?
Just good luck in your upgrades.
Yeah.
And Embarcadero is here to help.
Absolutely.
Yes.
Every step of the way. If you need us, then please remember we have our professional services available who can help you with the migration. But there's also the Upgrade and Migration Center with a lot of key resources online. So please use that as a start place. And but if you get stuck, we're here. So happy coding, everyone. Thanks very much for joining us, and see you again soon.
All right. Thank you.
Thank you.